I was a PwC partner in London previously to joining here for 4 years, and I was leading the data and analytics team in consulting there. Fujita-san leads the data team in data and analytics in consulting, and he has 20 years of professional experience in data architecture and data infrastructure. This afternoon we will talk about applying data analytics in business, and especially around 2 case studies related to the financial services industry. I'll start with setting a context and providing a few frameworks to think about data and analytics in the financial service industry. Then we will focus on a customer analytics case, and then on an operations analytics case involving AI. And the last section will be around the foundation for data that are required to apply data analytics in any situation. This slide probably shows what everyone in this room knows. From shifting from analog to digital, we've seen an explosion of data everywhere. That's not new. We've also had a gigantic progress in the computing power, which has made a lot of applications now feasible. The slide lists 20 ingredients that are generating enough data to create very useful applications. For example, facial recognition, plus intelligent personal assistant, plus digital identity management can combine to contribute to creating a virtual assistant. The new applications are already providing opportunity to deliver better, faster, cheaper service, more flexibility, and profitable growth for financial service players. And for regulators, they provide the ability to check everything. So framework number 1, definitions of data and analytics solutions. At PwC, we've created this simple framework organized around 7 areas. The first one on the bottom left is we need to discover and to trust data first. Second one in the middle, we describe, predict, and optimize situations. The third one towards the right, we empower organizations and we embed data analytics capabilities. On the right-hand side of the slide, you see questions that are typically asked by our clients. Second framework, where does value of data analytics application come from? The value comes from very many different elements. We've tried to look at when you design the solution, when you refine it, when you test it, and also when you apply it and scale it up. Value is in getting the right data to contribute to the analytics. That means the right quantity, quality, frequency, etc. The right visualization also of the data to provide new insights. The right analytics, not too complex, not too simple, especially within AI application, also explainable. Then there is the right decision, implemented correctly and quickly. Actually, without the right data on the left-hand side, an analytics solution is actually meaningless. So this is why we decided to present together with Fujita-san focusing on the data side of the equation. Without the right implementation, we also don't have anything. So it's not sufficient to create an analytics solution, it's sufficient to implement it. Final framework, problems that we can address in the FS area. We've organized it into customers, risk and regulation, operational, and big data. Of course, here are only a few potential solutions. I'm sure people have worked on many, many more, and there will be more applications coming up, probably every week. So now let me focus on the customer data analytics case. This is a relatively complex slide, apologies for that. This describes all the elements that a US bank is putting together, it's a retail bank, to try to create a financial wellness program for their customers. This is to help customers throughout their life of banking to have the right risk, the right investments, the right facilities throughout their life. The objectives of the bank were to develop ways to retain their best customers, not lose them, and to launch new products to attract more customers. This program is quite ambitious. It includes 3 data sources, that's the top row, 11 pre-built analytics modules, that's the middle row, and 3 analytics infrastructure components, that's the bottom row. I'll describe 2 of the components and藤田泰嗣will do the same. First, customer lifetime value. That's a very interesting and important tool if you want to be selective as a financial service player about the customers you have, the customers you attract, and the customer you let go. It requires having a measure of customer profitability by individual, and ideally a measure of profitability of all your products. So on the supply side, the product you offer, on the demand side, all the profitability of your customers. We usually recommend creating more than the 5 or 7 segments that are frequent. We go to micro-segments. We put together databases of a lot of information, demographic information, of course, bank data. If it's your customers, you should know a lot about them. We also look at neighborhood data, because we have their address. So we should be able to have information on the neighborhoods. And then behavioral data that might be revealed by their transaction, if they have a credit card with your organization, or other ways of collecting that kind of data. In some applications, we go to 100 microsegments or more. That allows you to put together segments of very homogeneous behaviors. Those might be young couple, urban, digital, who likes mobile banking. You can see how it shrinks a set of people. The beauty of this approach, it allows you to design solutions just for them. And by knowing their profitability, again that's important, and knowing which segment they are part of, then studying the segment to see the flow, the natural flow of customers from one microsegment to the next, you can start devising products that are just targeted for those people you want to keep, not anybody else. I just want to come back again on profitability. If you don't have profitability at the individual customer level, what I've described is very hard to implement. The second component I wanted to focus on is the use of natural language processing. Now, it may be a bit surprised of seeing natural language processing being used in that context. This is not for robo-advice, this is not for virtual assistant. If you look at the design of new programs in banks, they're often put together by product managers, product specialists, marketing managers, business development managers. All of those people know very well their area, and the problem is they know very well their area, but only their area. So by using natural language processing and applying it to harvest information on the internet about the component of the program you want to create, what is out there with your competition, social forums where people discuss having a higher debt limit, let's say, at various parts of their life, looking at product information that are on your competitor's website, you can get an independent view of what's available at this time. That, plus the deep knowledge of your customer at the micro-segment level, allows you to essentially generate those exact products that will help you in an independent way. So the NLP component is a way to make sure you're not being biased by the information within your own company. Okay?
藤田です。PwC コンサルティング合同会社でデータ&アナリティクスでチームオペレーションのリードをさせていただいています。ヤンから冒頭でご説明がありましたけれども、主にデータ領域を担当しており、約20年後のコンサルティングの経験を持っております。ここからは利活用のために必ず必要になってくるデータというものについて着目してお話をさせていただこうと思います。これは先ほどヤンが説明をした某銀行さんのこのケース1における顧客個別レベルでその収益性を最大化して、把握してあげて最大化し、顧客でなくなることを防いでいくといったようなトータルでの施策を支えるフレームワークを再掲したものなんですけれども、私がお話しするのは一番上の枠の中 D と E の部分です。これがデータソースにあたるんですけれども、ここのは大変複雑なものになっているんですけど、できるだけ簡単にご説明しようと思います。まずこのケースでは大きく3つのデータソースのストリームがありました。これを分類すると、顧客を中心とした情報というものと外部環境的な情報、この2つに大きく大別されます。今ここに映している D のエリアに関して言うと、これは顧客を中心とした情報についてです。この部分はさらに2つに分かれていまして、1つは顧客個人の情報、顧客個人に関わる情報、そしてもう1つが顧客の家族を含めた家計の情報に分かれています。でこれらは単一のソースから得られたものではなくて、中で合成をしてそれぞれ作っています。どれくらいの合成量かと言いますと、顧客個人の情報、言ってみると個々の消費者総合情報データという形になるんですけれども、社内固有の独自ソース、それから、複数のパブリックソース、さらにPwC が独自で持っているデータについて構成をしているんですけれども、パブリックデータのボリュームは実に3億3000万を取り扱っています。一方で家計の情報、これは家計合成のデータという形になるんですけれども、こちらはアメリカの家計全体を代表する世帯レベルのデータ、約4000ぐらいの調査レポートなんですけれども、これを、合成をして作ったものになります。でこれら顧客を中心とするデータというものに、情報というものに加えて、デジタル調査データとして大きな動向をつかむ、データも利用しています。これが3つ目のストリームになるんですけれども、こちらはアメリカの人口が反映されている人口に対する習慣であったりとか、好みの傾向であったりとか、といったものを年間の消費者の行動を通して把握しているオンライン調査によるものです。 基本的にその消費者基盤内の財務活動のタイプ別の洞察であったり、年度でごとにまたがった動向であったりというものを捕まえることができるというものになります。かつて、これまでのソースデータというと、生のデータ、国家のシステムが吐き出しているログであったり、トランザクションといったものがソースデータとして扱われてきたと思います。ですが、顧客一人一人に対してそれをポートフォリオにどう組もうか、離れていってしまうのをどう捉えるかというのをセグメントではなくてマイクロレベルで捕まえようというところまでやっていこうとすると、ただの、真の意味でのソースデータという形ではなくて、ソースデータを生み出さなければいけないというのが現状になっています。そうすると一つのデータを一括で管理する、セントラルで管理するような仕掛けを用意しなければいけませんので、社内発生のデータ、それから履歴、社内の知識の結集にとどまらず、社外由来のデータであったり、パブリックデータというのも取り込んで、新たなデータソースに仕上げていく基盤、これがデータ管理プラットフォーム、DMP というもののコンセプトになります。この銀行さんではこのコンセプトに基づいた DMP という仕掛けをですね、用意して、実現をしています。やっていることはユーザーデータを収集して合成して再ソース化するというもので、データ駆動型の経営を行っていくためのエンジン、データ駆動型エンジンの実現に寄与しているものになります。先ほどのコンセプトに従ってですね、顧客のデータの中央管理から再ソース化というものを実現しています。顧客データを中央管理する、この実現の難しさというのは非常に難しいというのは多分感じになるかと思うんですけども、挑戦する価値を十分にあるというふうに思っています。これまでバラバラに利用してきたシステムがデータレベルで統合される、顧客一人一人に対するきめ細やかな情報把握とともにきめ細やかに施策を実現することができる基盤といったものになっていきます。では次のケースに進みたいと思います。皆さん、
So now let's move on the next case. This one was on customer analytics in retail bank. The next one is on operations, and a little bit of customer, but operations in a corporate banking and wealth management area. So this was a project that I worked on with my team about a year ago in the UK. This was for a large European bank looking to provide 24/7 support to their wealth and corporate clients in Europe. Obviously, relationship managers are still absolutely part of the delivery, but they do take weekends and they do sleep at night. The bank was trying to look to test if it could automate some processes by creating virtual assistants to be used in addition to the relationship managers. We teamed up with HP Enterprise Software, now called Micro Focus. PwC provided business and industry expertise, HPE provided software and theoretical expertise. The virtual assistant was designed to interact with customers in a natural way, to understand quickly their question and identify their intentions, to provide detailed information about wealth or corporate bank products, such as loan, interest rate, etc., to organize a meeting with their relationship managers, to execute even a transaction if need be, to use machine learning during training and during usage to improve understanding of complex user questions. Those were the four elements that I mentioned. The dialogue architecture is flexible. Our client asked to focus on serving corporate banking clients and helping relationship managers retrieve very quickly facts about their clients or the market. Fact retrieval, we were asked to access publicly available information from Yahoo Finance as well as company websites. The example on the site on the slide here is, that's the one. It is written quite small, so if you see at the top who is the CFO of Majestic Wine, the CFO of Magic. So on the blue is the relationship manager, and on the left in black is the answer of the virtual assistant. So all those questions are fact-based. That's one application that we were asked to put together. The reason they asked us to do a modular and flexible approach was they wanted to test it in a small context and then reproduce it after that. Now this is I'm going to play you a very silent film with very small writing, so I will pause it from time to time to read it. This is the demo we had put together. This is a film of the demo. The demo was live. It interacted, it got the information directly. Our clients were asking the questions, there was no script. So there is a bar here where the client enters the questions. I'd like to enter into an interest rate swap. The virtual assistant answers, and I'm going to pause because it's very hard to read. My understanding is that you're looking for interest rate hedging. Before I assist you with that, I need a few details. Firstly, can you tell me your name, please? This is important because those are supposed to be clients of the bank for which all regulatory processes have already been completed and are valid. That means no anti-money laundering issues, no knowing your customer KYC problems. So, Helen Ashton, what information? So, the assistant said, can I ask you to tell me the name of the organization you're representing here today? ASOS, it's a direct online website. Okay, moving on. I can see you on our system. Can you confirm that you are Ellen Ashton? Yes, I am. Thanks. What would you like to know more about interest rate swap? Rate hedging. So the interesting here is the conversation continues. There has been a diversion on checking identity, coming back to the first topic. So we continue the conversation. She says, I want to do a swap. Do you want to talk to a relationship manager? Not really, I want to do it myself. Then some technical information on giving the parameter for the swap, the index, whether she wants to pay or received, what period she wants to hedge, a confirmation questions. Do you want to execute, or would you prefer to speak to a fixed income sales representative? And then let me pause it here too. Here is a question that has nothing to do with the previous discussion. Everything was on interest swaps, and now she's asking what's the current share price of my company. In fact, there's even a spelling mistake which she will correct. Keep that in your mind, we'll come back to it later on. So this was essentially one of our clients deciding to play a trick on us during the test of the system. So those were essentially the major components of the program. The virtual assistant has 4 components. So the illustration here focused on very many tricks. To deliver that, we had to have an unstructured data management component, a question and answer component, an AI natural language system, and some machine learning and augmented intelligence, which is a little bit fancy, but actually it's a little bit true. So let me walk you through some of those details. First component, the unstructured data management. This is a relatively simple part of the problem, except that it does one extra thing very well. When you ask a question, of a specific structure related to facts, the virtual assistant essentially goes to Yahoo Finance as the default, but also to all the direct client websites they can find, search for anything that's to do with their annual report, and inside the annual report reads automatically this report to extract key facts. That's not very hugely difficult, plenty of tools do that. What's slightly more difficult is to extract specific numbers from tables, which is slightly more complex to do in the context. Remember, that was done about a year ago. So at the end, it generates a summary which is for the use of the relationship manager or for the use of somebody controlling what's happening with the system. So that's the first component, unstructured data management. The second component is question and answer. There are very many types of question and answers. There are some where the intent is quite clear directly from the question, and that's one of those types. It's a factual questions. What was the revenue of ASOS in the UK? Now, there is no time period perhaps, but at least we know exactly what they're talking about. So the structure of the question and answer system is to recognize those simple questions apart from the more complex one. It has, we've built an inventory of simple grammatical structure, things that start by what, who, where, etc. And then there are several components that modify that questions. We know that the subject is ASOS. We know that the qualifier is in the UK. We also know that there are some property revenue and a process domain. Each one of those can be described relatively thoroughly in advance. Okay? So if you have here we are slightly cheating because people will say, well, this is not real. Yeah, you have a tree of questions and you walk through the tree and you find the question that works. It's a hybrid system. It has a tree of structures. We find very quickly the right structure, and then after that we apply understanding of the questions to be able to extract the right facts. If the question is not a simple question, but one more with potential misunderstanding, overlap of meanings, we have created a dialogue system that describes the task that a relationship manager, in this instance a fixed-income banker working in a corporate banking division, would be expected to cover when they interact with their clients. So if we start from the left to the right, the first column has to do with admin tasks that anybody, even people, actually have to do. The second column has to do with the ability to answer questions and to ask questions. Again, whether it's a robot or a human, you still have to deal with those. Those are general skills. And then from then on to the right of the slide, those are specific domains in which the fixed income banker is supposed to know the products, the situation, being able to do some diagnosis. So we've put together this framework with, here you see a few subtasks, we have even more, to help the dialogue system detect the intent of the questions. And we'll see how that works in the next slide. So if we have a question, as Helen Ashton asked about interest swap, the customer question comes in the bubble, the machine learning topic detection finds out the keywords, identifies interest rate hedging as the potential topic, and starts asking questions on exactly what she wants. This is where the meaning is refined over time. And we have also, if you remember this question, this weird question about the share price of our company right in midstream, think about it as a parallel questioning stream rather than an interruption. You have a new stream coming in to say, what's my share price? To be able to handle those interruption is quite difficult because you have to decide whether the new question is part of the current stream or is a new stream. So with the ability that we'll see in the next slide on putting probabilities on topics, we're able also to handle and recognize quickly which topic they are in from. Now we still have to deal with them, so in which order should you deal with this? And the principle we've used is the last in, first out process, saying that if the human client asks a question that has nothing to do with what we were discussing, that means they want an answer quickly. And so the focus is on answering the last question that came in first. Okay, this is the LIFO question handler. So now, how do we decide what topic to look at? The question from the client or from the customers is, how do I borrow money to invest in a new production line? This was one of the test cases we had with a very uneducated CEO, or uneducated in terms of finance, didn't know what question to ask exactly. So I've put in red the most important words in the question. Borrow, money, invest, new. Why is production line not important? Actually, it's context dependent. We're not dealing with manufacturing application, we're dealing with finance application. Therefore, production line is very easily pushed aside. The green lines indicate the potential contribution to each of the main topic, which you can see here around loan, FX hedging, etc., from various words. So for each word, we diagnose with a weight, probability, whether that word is linked to various meanings. And then we estimate the overall probability that the topic is loan credit line investing on the right-hand side by combining the weights of all those words. Okay? Now, on the first time we do that, it's usually quite poor results. So once we submit a whole bunch of documents, for example, all the banks' internal documents describing their products, all the competitors' documents on their products, all the situations because they have been listening to their clients and they've recorded the conversation. We put all that through the machine learning algorithm, and little by little we refine and the estimates become more and more accurate. In this particular case, it's not enough. The difference between 42% and 31.5% in our estimation is not enough to be exactly sure what she's talking about, which is why we then generate, this is not natural language reading, it's natural language generation now, a question to help us find out more about which topic it is. Okay? And final element, the cognitive analytics bit of the equations. This is essentially the same type of structure that we had before. The little dots are subtopics. So the previous slide had simple number of dots. I've showed the hierarchy of tasks at a high level. We had many more layers of that, as you can probably imagine. And the idea is, in the front of the brain, if you wish, you have a common inventory of the topics you're dealing with. So deep down we have interest rate hedging, we talk about swaps, we then have web queries, and they are actually structured in that order. And they access the overall task frameworks with the weight of probability. That's kind of the back of the processing machine. And if a client questions come in, it is then passed on to the structure and then processed into the frontal zone to be able to ask question and answers and read answers. Okay? This is the best way we found to explain a little bit how the structure of the algorithm is actually not very far from the structure of the way human process information. And that was quite innovative at the time, especially with working with people that in the past had not been associated with great advance in cognitive computing. Okay, so it's enough of the details on that case. A few takeaway. If I look at this list of setting up an AI implementation framework, we've made our own mistakes. The clients definitely made their own mistakes. We found that actually an implementation that goes through cycles and refine, define the problem, define an AI architecture. Slides are taking a life of their own. You then build a knowledge base and build an AI application, and you start again, because the problem has changed a little bit, you know more about it, you know more granularity, and go deeper. And it's through several cycles of this that you can find something that's actually useful and employable. Final point, in banking of course, but in lots of areas, I can think of facial recognition causing a few problems in that. At some point, somebody, either a regulator or somebody else, will ask questions. Okay, your AI told me this answer, why? How do you justify that? And so this is where you may have heard about it, explainable AI is quite important. And it's gonna be, this is really hard. Because machine learning learns very, very quickly through gazillions cases. And being able to explain and put a report together of why the recommendation was based on various facts is very important. Here, an example of what we're working on at PwC right now, which is a suitability index. We choose one variable, we say this is suitable, not suitable, and then we go down to the weight of each of the factors and explain whether a case that's been proposed to be suitable actually is, there are several factors contributing to the fact that it's suitable, several factors that contribute to the opposite. So the green are good factors and the red are bad factors. This is a not very telling story. It's likely to be suitable, but maybe not. Okay.
さて、今 AI を使って実際にバーチャルアシスタントを実現しましたよ。こんなふうに考えてやったんですよ。私はヤンから知っていただいたんですけれども、ヤンが何をしていた AI によるバーチャルアシスタントっていうのも前に書かせていただいている通り、運用して実装していくためにはどうしてもきちんとしたレイヤーを垂直統合していく必要性があります。技術的にいろんな技術がひしめになっていますので、これをどのように組み合わせていくのかっていうのは非常に重要なポイントになっています。例えば今お話をしていた AI についてなんですけれども、 AI は常識がないんですね。ですので人間が、これだったら当たり前だよね、例えばスペルミスを先ほどヤンは出してましたけども、スペルミスであったりとか、それからこれは誰が言ってるのっていうのは人間であればすぐ様式的に考えてうちの CFO っていうふうに分かるんですね。なんですが同音異義語であったりとか、そういう分かりにくいものについて AI では実は判断がつきません。ですので人間らしい振る舞いをさせようと思えば思うと非常に難しくなっている。そこで先ほど話が出ていた PwC 独自の工夫であるところのそのライフォータスクハンドラーというものを使ってシングルでシーケンシャルに考えていたものをマルチシーケンシャルにしてあるので、あたかも人間がのようにより人間らしいと言ったらいいですか、より人間らしい振る舞いをするような、実現をしています。でこの設計を可能にしているアーキテクチャデザインを噛んじゃいました。この設計を可能にしたアーキテクチャデザインというのは特筆することができるものだなというふうに思っています。でもう一つ重要なポイントがこれは日本に限らずなんですけど、日本に特に強く現れる傾向なんですけども、 AI 利用しようと思う弱点が一つ大きいものがあります。それが特に金換算があるんですけれども、説明性能ですね。なんで AI がこの答えに至ったのか説明してくるというものが非常に強く出てくる。これは説明可能性なんですけれども、これが、強く求められます。 これをちゃんと説明できるようにするっていうこともアーキテクチャに強く依存してきます。アーキテクチャが分かっていれば最後にヤンが見せていたところが PwC の強みですよというお話になるんですけれども、きちんと説明が AI が出した答えがなぜそういう答えに至ったのかという説明ができるようになっています。4層で、ここに挙げている4層で、アーキテクチャデザインからツールの選定、設定、アーキテクチャの設計というのは、検討というのが成果を大きく左右すると言えます。ちなみに今回の、このケースでおいては、HP のアイドルを総合層等々で利用して実現をしております。はい。さて、ここまでケース1、2と見てご説明をしてきたんですけれども、最後にデータ、これらを実現するためにはどうしても基礎的な部分としてデータの部分をどう整えるのかというのが発生してきますので、ここについて私の方から少しお時間をいただきながらお話をさせていただきたいと思います。そもそもアナリティクスであったりとか、分析であったりとか、AI であったりとか、華々しく話がされているんですけれども、これを支えているのは全てデータです。よくある話がデータくれと言ったら出てこない。データあるんだけど使い方が分かんない。こんな話で社内全然動かない。何ことがあるんじゃないかと思います。いかに使えるようにデータを整えていくのか。先ほど、前に出てきた時にお話しさせていただいた、DMP という考え方、データソースからデータソースを作り出さなきゃいけない、この複雑な状況というのをどう実現していくのかというのが非常に重要なポイントになってきています。日本であまり大きく成果が取り沙汰されてこないのは、一つには大きい海外との違いというのがあるというふうに我々は考えています。その一つがデータの売買市場の成熟です。先ほどのヤンの説明の中でケース1、ケース2においてもですね、外のデータを活用しているというのが非常に多いです。何億件というデータ、4000という調査結果なんていう話を私させていただきました。これらすべて外のデータです。パブリックデータ、公で公開されているデータについても同じことが言えます。日本ではまだ数百のレベルしか過ぎません。ですので、グローバルでは外のデータ、我々自分の自社の中にあるデータだけを使ってやっていくんじゃなくて、外のデータをいかに活用するのかというのが一つの大きいポイントになってきます。一方で日本ではどうしても社内のデータに偏らざるを得ないというのが現状です。そうは言っても海外に置いてかれるわけにいかないので、いかにクイックにスタートするのかというのがポイントになるんですけれども、社内のデータの利活用を開始すると同時に、その外部データの利用取得利用をですね、検討していく必要性があります。ですので、インターナルでデータを作ってクイックに結果を出しながらデータの基盤を整えていく、データ管理の基盤を整えていく。また自社のデータを加工して売買していく、要は今成熟していないデータを売買するプレイヤーとして打って出るためにも、社内のデータというのをいかに活用するのかというところが一つのポイントになってきます。日本ではその PDCA というのは非常に好かれているんですけれども、 PDCA という行為は基本的にスピードを上げることができません。特に日本ではスピードを上げることができません。これの一つのいい例が倫理やってると計画にバカみたいに時間がかかると、当然のことなら前に進まないということになります。PDCA って保守にあたってですね、直して保守を繰り返していくということになります。そうすると前の保守に次の保守が引きずられます。最初の設計に保守が引きずられる。 そうするといつかそれは技術的な負債になっていってしまいます。 PDCA 回せば回すほど技術的な負債が溜まっていって負債ですのでどっかでいっぺんに返さなきゃいけない。これが PDCA の一番辛いところなんですね。で日本においてよくアジャイルっていうのもこのせいで動かないんですけれども、日本においてじゃあうまくいくやり方ってどんなやり方があるのかというと、一つのアイデアとしてはこのウーダループっていうのが考えられるだろうと。まず見える化っていうもので社内の何かを捕まえる、社外の何かを捕まえる、兆候を捕まえるなんていうのをもうすでに取り組まれてきた。なのでまず気づきを得るところ、オブザーブのところはもうできているんです。観察をする仕掛けは日本ではもう出来上がっていると思います。そして情勢を判断するとここが少し遅れているかなというふうに思っているんですけども、日本の会社の中における知識と経験の結集はすでに皆さん取り組まれています。ナレッジマネジメント、コンテンツマネジメント、ビジネスインテリジェンス、アナリティクスといったようなもので実はできています。社内の情報を使うところは先ほどお話ししました。非常に難しい。まだデータ売買もできてないので非常に難しい状況だというのは分かっていますが、ここは社内の情報を使って何かを作ることを出すことはできると思います。知識と経験、これを結集すると意思決定ができます。決めることができます。やるかやらない。やらないと決めればやらなくていいんです。やると決めたらすぐ実行です。実行するとモニターの仕掛け、先ほど言いました見える化をしてきたので、モニターの仕掛けで変化を捕まえることができます。すでにもう皆さんのところで手がけてきた、特に金さんなんかでは、リアルタイムで捕まえることに特化していろんなことを入れてきていらっしゃる。そういう中では非常にいいサイクルを作ることができるというものになってきます。ビッグデータというふうに懸念されてきたので、データ量と種類というのはまさにビッグになってきているんですけれども、データマネジメント基盤というものを使って正確さを加えてバリューを生んでいきましょうというのが、最近のコンセプトなのかなというふうに我々は思っています。一般的にそのデータマネジメントの構成というのはよくあるそのデータをソースデータからデータをインテグレーションする仕掛けがあってっていうこういう形で書かれるんですけれども、実際にこれの絵だけの通り、この絵の通りに例えばアーキテクチャ組んだからといってうまくいくことはやりません。先ほどのお話もさせていただきましたけども、アーキテクチャの検討非常に重要になってきます。で皆さんこういう絵を出すとですね、ある程度データマネジメントプラットフォームができてるんだとこういうふうにおっしゃるところが多いんですけれども、大体その本当にできてるかどうかというのを自己チェックする方法が一つあります。ちょっとこれをご紹介しようと思います。これは何かというと、データリンケージですねがちゃんと把握できているのかどうかというのが非常に有効です。データをちゃんとガバナンスをコード化してより正確にしていく、大量のデータを取っていく、社内のデータを利活用していくといった時にデータ連携系統図、どこがどこにつながっていくというものがちゃんと書けるのか、書けているか、逆に言うとこれがないとですね、複雑に絡んでいるデータの流れの中でどこに問題があるのか、どこが使えるんだろう、直すのはどこが必要で何を直さないとダメなんだという優先度の判断もできます。基本的にその辞書情報ですね、何がどこにあるというと辞書的な情報であったりとか取得協力っていったものを持ってですね、このリンケージがちゃんと取れているのか、データの系統図が取れているのかっていうところでご判断いただければ、自社の仕掛けがどれぐらいいけてるのか、これからの変化に耐えうる形になっているのかっていうのが、判断できるかと思います。ちょっとこれサンプルまでに、お出ししているんですけれども、データの系統図ですね、こういったものが準備できていればいいと思います。
So that's going to be my last slide. We've talked about big data problems. We've talked about choosing the right algorithm. We've talked about value coming from decisions. In my experience, an approach of co-designing with the users, piloting and refining and implementing progressively is very useful. But despite everything we've told you, the hardest part is not finding the right data. It is not about visualizing the right data. It's not about finding the right algorithm and analytics. My experience is it's quite often realizing going from a paper solution to a real solution. So I've seen a lot of applications creating fantastic solutions. They're on paper. And then politics in the company gets in. Or it's too hard. Or not this year. Or it's not the right time. So the most difficult part actually goes back to us, humans. Even with AI. You need to change the process, you need to change the culture, you need to change the way people act. And a lot of them feel not quite in agreement. And that's where the most resilient part of human beings come in, resistance to change. And so for me, the toughest part of data analytics application in business is not data, it's not application, it is the business part of making a theoretical result a reality. Fujita-san, another word?
データの方から結論なんですけども、データ駆動型のデータ駆動型エンジンというものを実現するためには、データマネジメントプラットフォームのコンセプト、これはフィンテックというテックの部分なんですけども、これの確立が重要になってきます。データを集めてきて合成して新しいソースデータに仕立てていく、そういうプラットフォームとしての、データマネジメントプラットフォームというものが、今後非常に重要なポイントになってくるのかなと。たくさんの技術が出てきていますので、それをどう組み合わせてどう生かしていくのかというのが大きいポイントになると思っています。
Thank you very much for coming, and I hope this was helpful. We're staying here for comments if you want to ask individual questions. Thank you.